All right. Okay. So hello, dears. Welcome to the part two of our yes, of our lecture on the different on agglutination reactions. Okay, medyo may buffering doon. Okay. All right. Ayan. So for this part, we're going now to discuss the different types of agglutination. All right. So as you can see, daghan siyang types. As mentioned, diba, you will encounter agglutination also in blood banking. Alright? So sa inyong mga lab procedures, tanan mong lab procedures, mostly sa mong blood banking, you are to grade agglutination. So katong table na to ganina, alright? I think i-discuss po na or i-emphasize po na sa blood banking. So please try to memorize it by heart. Alright? Okay, but mas okay good na siya if in person or face-to-face. But sige lang, laban lang tao, atay choice, visit na gobyerno. Anyway, alright, so I have to emphasize also when grading sa tube, guys, usually what we do is tube, no? You shake and then amo siyang i-put or i-compare nimo siya or to grade, you put it against the light para makakita ka. Alright, so mo siyang i-ana. Okay? Alright, and then i-check na siya if it's 1+, 2+, 3+, or 4+. Okay? Alright, ayan. Sige, so we'll now go to the different types of agglutination reactions. They're quite a lot, no? So we'll go individually. Alright, so different types. So we'll start first with direct agglutination. So when you say direct agglutination, the agglutination happens because the antigens are naturally found, meaning they are really found there naturally. Like wala sila gibutang dito artificially, wala gi-introduce ang antigens sa lab, all right? It's really there, found there naturally. They are found naturally on the surface of the particle. Example, antigens sa bacteria and your antigens also na naa sa mong RBC na surface. That is why we have mga blood typing, or that's why we have blood typing. All right? So, yeah, that's an example of naturally occurring antigens. Okay? So, it's naturally innate na yun, na nila daan. All right? Ang antigens. Okay. And heme agglutination, by the name itself, nasa ngalan, heme agglutination. So, heme, it uses red blood cells. If ang agglutination involves red blood cells. So, example, of course, your ABO blood typing, it determines your ABO blood type using the different A and B anti-sera. So, when you say anti-sera, di ba? Anti-sera. So, A anti-sera, B anti-sera. So, therefore, it means it contains anti-A and it contains the anti-B. So, kanimong anti-sera, it contains antibodies. Alright? Okay. Ayan. So, here's an example. Your anti-B reagent or your B anti-sera plus the B antigen, of course, because they're specific. So, they now result to agglutination. All right. And another example is the Widal test. Again, as mentioned, we will discuss this in salmonella serology. All right. So it's an agglutination test for the diagnosis or detecting antibodies to salmonella, which causes typhoid fever. So you detect antigens or antibodies against the somatic O and flagellar H antigen of your salmonella. Diba? In our bacte, last I discussed with my classes the somatic O, capsular K, diba? Flagellar H. All right, so we'll know that later when we go to salmonella serology. Unsay mga meaning ana. So you have the H antigen and you detect for antibodies sa sample. So the main point is that it's direct agglutination because again, the antigens are naturally found on the surface of the particle. So we are testing mga particles na ang ilang antigens kay naturally found there sa ilang surface. Okay? That's the point of direct agglutination. Alright? Okay? I hope na-gets lang. I hope that's clear. Alright. Ayan. So, okay. Sige. Next, we go now to ABO blood typing. An example, di ba? You have the B erythrocytes or your red blood cells if you have the blood group B. So, ang naay mong antigens sa surface, sa RBCs kay the B antigens. And of course, your anti-sera, which is anti-B, in this picture kay IgM yung itsura, of course, it causes agglutination because again, they react. So, muna ato makita sa ato ang blood typing. So, if mo clump siya or na mga clumping sa imuhang B, di ba, na circle or na field, then muna imo pag-interpret kay B, no? Blood group B, and then kung na RH, B positive ba or B negative. Alright? Okay, ayan. So always take note lang guys, a rule in blood banking, the antigens are always found on the surface, okay? And the antibodies are found in serum, okay, or in your plasma. That's a basic rule or major rule in, a fundamental rule in blood banking. You'll be introduced to that also. That always take note, always remember that the antigens are on the surface of your RBCs, whereas your antibodies are in your serum or plasma. Alright? Okay, ayan. So, blood banking na yun. Okay. Alright, that's for direct. Next, we go na to passive or indirect. When you say passive or indirect, ang difference lang, ani, is ang antigens dili naturally found on the surface of the carrier, okay? Or surface of a particle, okay? The antigens there are not normally found, but gibutang siya dito. Alright? Maybe through artificial methods, sa laboratory, mga inana. Alright? Okay. Yes. So, mga particles that are coated with the antigens but are not antigens that are not normally found. Sorry, not normally found on the surface of the particles. Okay. So the particles can still be erythrocytes, latex, gelatin, or silicates. Pinaka-common usually na ito ma-encounter ka ng latex. Okay. Mga latex agglutination. Okay. Na po yung RBCs. Alright. Okay, so we detect again antibodies such as the rheumatoid factor. We'll have a discussion in this when we go to serology of rheumatoid arthritis. Okay, we'll have that soon. Anti-nuclear antibody, usually mga autoimmune diseases. Antibodies to Trichinella, sorry. Trichinella spiralis and Treponema pallidum. Okay, so mga parasitic and bacterial disease. And antibodies to viruses. Alright, so we detect antibodies. So in 1955, Singer and Plotz, it was found that they found out that IgG was naturally adsorbed to the surface of polystyrene latex particles. So adsorption meaning adhesion. So Singer and Plotz discovered that the IgG can be attracted or can be put on the surface of latex. Okay, so ilang gigamit niya siya na parang idea, all right, to use for other, like let's say antigens this time or other methods. Okay. Alright, so ayan. So we have a carrier particle again, di ba? Sa ato ang intro in antigen antibodies na lecture. Ada nimo og atong antigen na soluble. Okay, so since soluble man ni siya, if wala carrier, di ba? So if mo react sila dili makita. Because again, this is soluble, so mura siyang precipitation, di ba? But ato siyang gibutangan og carrier para ma-visible imong agglutination. Mas mudako ang antigen kay sila naman na together, di ba? Alright, ang immunogen or antigen para mas maklaro imong reaction. Okay? Alright, so the combination of the two, it now results to the coated particle. So this is now what is found in your mga reagents, no? Ani na mga tests. But mura siya, in a nutshell, ang idea ra good or ang concept sa passive or indirect agglutination is that the antigens are not normally found on the particle. Okay, so they were artificially put there ba, gi-coat sila artificially basin sa manufacturer or sa lab, inana. So that's the difference between direct and of course the indirect or passive agglutination. Okay, all right. So here's an example of a picture. So coated particles plus the antibodies will then result to agglutination. So still the same, follows the principle of agglutination, lattice formation, and all that. Okay, all right. So basically what we're detecting is patient's antibody. So we want to check if nabay antibody na na-produce ang patient. So ang direct o indirect, usually, we detect for antibodies. But ang direct, pwede po mo detect like antigen. Okay. But kanina ang passive or indirect, usually mo detect ang antibody. So we detect if the patient has antibodies ba to this disease, particular disease ba or condition. Okay. For reverse passive, okay, by the name itself, reverse passive, instead of antigens ang ibutang sa artificial na mga particles, you then put antibodies. So, reverse passive. So, opposite ra sa passive, munang reverse passive. So, instead of antigens ang ibutang sa latex particle, let's say, or erythrocytes, antibodies imong ibutang. Okay? So, opposite of passive. Alright. Is attached to the carrier particle. They must still be reactive. And that, so example ni latex, of course, ang imuhang antibodies dapat outward. Because again, diri man ang binding sites, your Fab. Okay? Alright. Ayan. So, for this time, since antibodies man ang naas ato ang latex or carrier, siya ang atong reagent. So, therefore, we are looking for, or we are detecting antigens this time. So, it's usually used for infectious agents, therapeutic drugs, not even mga therapeutic drugs, di ay not only diseases, Also mga proteins, hormones, haptoglobin, and CRP. Alright, so reverse passive. By the name itself, you're detecting the antigen, okay? Or you're detecting antigens, okay? In the form of bacterial antigen ba? Or it could be just like normal proteins kung saan mo ganahang i-detect. Basta ang key concept lang yun is instead of antigens, ang ibutang sa imuhang carrier, like example latex, you put antibodies, alright? So, muna siya difference sa reverse passive and passive. So, where the name is self-passive, okay, and reverse passive, so opposite. Alright, okay. So here's an example, carrier particle, you add the antibodies, and you have your coated particle. As mentioned, dapat outside ang imuhang kaning Y, because again, these are your Fab. That's the fragment antibinding, fragment binding sites. Or your fragment antigen binding sites di ay. So, muna siya ang dira mo bind. So, sila ang mo participate sa pag-agglutinate. Alright? So, dapat ang imuhang Fab ang outward. Okay, all right. And the FC, di ba, recall sa ato ang antigens antibodies, the FC portion of the antibody is used for other functions niya. So, pwedeng complement or pwedeng pangpatapot diri in ana. All right? Okay. Ayan. So, here's an example of a reaction. So, you have the coated particles, yung reagents. You are detecting antigens, okay, from a sample. So, of course, mo bind sila, and then they form a lattice network to then, which will result then to visible agglutination. All right. So, I hope na gets lang ang concept. It's quite simple lang naman. Basta, from the start, direct agglutination, the antigens are naturally found on the surface of the particle. So, example, kung RBC si mong gamiton, so heme agglutination, the antigens there are naturally found. So, naagyo sila dito. Pag panganak pa lang sa bata or sa patient, ang antigens mismo na nadaan sa RBCs. Alright? Walay nahitabo na parang disease or whatever, it's naturally found, naaraguna niya daan. Sa sukad-sukad pa lang. Alright? Direct agglutination, if ang antigens inana. Next, indirect is the antigens are not normally found sa particle. Alright? So it could be that the antigens were introduced artificially through a lab, through the manufacturer, whatever. Alright? Okay, ayan. And lastly, reverse passive is the opposite lang. Instead of antigens imong ibutang sa artificial na carrier, you put antibodies instead. Okay? Alright? I hope, in a nutshell mo na siya. So I hope di na mo malibog. Okay? Alright, ayan. Sige, that's for reverse passive. Okay. Alright. So basically, for reverse passive, since antibodies mo na nasa reagent, so you're detecting antigens. You're detecting antigens sa imuhang patient. Whereas ang passive, kay since antigens man ang naa sa imong reagent, dire ang naka-coat sa particle, so you're detecting antibodies sa patient sample. For passive na siya na agglutination. Okay? I hope na gets lang. Alright, ayan. Okay. And next we have another type, your agglutination inhibition. So by the name itself, agglutination inhibition. So naay inhibition. So naay pag-stop, char. So naay paghunong, charot. Okay? Alright, ayan. So it's based on the competition. So naay competition na mahitabo. Ayan. So kinsa man dyan madoog, no? Competitive ni sila, guys. Char. Competition between the particulate and soluble antigens antibodies for limited antibody combining sites. Actually, mas makasabot mo ni sa illustration later. Alright. Ang positive reaction natin dira is lack of agglutination. So nga naman, sige, we'll look into the illustration in a while. And if RBC is still the same, basta na gani RBCs na included, mabutan siya tag heme. So heme agglutination inhibition. Oh, di ba? Heme agglutination inhibition. Basta na RBCs na involved. Pero for ara, that's normal agglutination inhibition. Okay, all right. And either antigen or antibody can be attached to the indicator particles. And as you can see, pwedeng mo detect kag antigens, pwede po ka mo detect kag antibodies. Depende ra gyud sa imuhang test, okay, or on what you want to determine. All right. So here's an example, antigen-coated ang particle. So ang particle mismo kay antigen-coated. So unsa man atong gine-detect? Antibodies. So we want to detect if the patient has antibodies, okay? Because the antigen is, the coated particle has the antigen man. Okay, all right. So to detect the antibodies. Or your antibody-coated particle to detect your antigen. So pwede ra either way. All right? Okay, so again, you'll encounter this principle sa inyong blood banking. There's a test there in blood bank known as your saliva test. Okay, saliva test. Ayan, the saliva test. You detect mga A or B antigens sa imong secretions, and one of that is saliva. All right, so you'll experience that in your blood banking. But the principle is agglutination inhibition. Okay, all right. So we'll now go to the illustration para mas makasabot mo on why is it named agglutination inhibition. Alright. Okay. Ayan. So, and saliva test there, guys, do not be confused. Our saliva test sa blood bank with the saliva test sa pag-detect sa COVID. That's a PCR test pa rin, pero saliva ang sample. Yeah, I think the Red Cross is, using that test now. Ang saliva test sa BB, lahi ang detect, okay? Ang saliva test for COVID, it's still the same, RT-PCR Japon, reverse transcriptase PCR, pero ang sample ni mo ay saliva instead of the nasal swab. Alright, okay. Wala, chika lang. Alright, basin maglibog mo ba? Alright, okay. Now, let's say you have a reagent antibody. So, you have antibodies, reagent daan. So, mga known antibodies. Now, you have a patient sample that contains the antigen. Okay. Now, you incubate, so para mo react sila. Alright? So, the antigen present, if antigen is present, rather. Okay, sige. We have two scenarios. Alright. So, example, the patient has the antigen ko, no? So, of course, the antigen present in the sample, mo react siya with the reagent antibodies. Alright? So, imo siyang incubate, so nag-combine sila. Alright. Now, imong adan sa imuhang antigen-coated latex particles. Now, question, do you think na dyan po yung mahitabo na reaction or wala? Sige, 3, 2, na mag-agglutinate na ba dyan sila or wala na? Okay, na pa ba? Okay, sige. Time's up. Pack, press the buzzer. Of course, because the antibodies have already been binded by the antigens present in your sample, wala na yung antibodies na pwedeng mubind ani nila. Therefore, walay agglutination na mahitabo. Gets? Because the antibodies in the reagent have already been binded already or have already been combined, nag-react na daan with the sample, with the patient sample that contains the antigen. Okay? So, diri pa lang daan ni-react na. Pag-add di mo og reagent na antigen-coated, so kanina mga antibodies, dili na sila free. Okay? Wala na sila other binding sites to bind these latex particles. So what happens? Walay mahitabong agglutination. And that indicates na positive siya for the antigen. Gets? Because again, wala na agglutination na hitabo, it means that the patient has the antigen for this particular disease ba or for this particular bacteria, whatever. Alright? Because it means that naman siya antigens daan, diri pa lang, ni-react na siya with the antibodies found in the reagent. Okay? So, pag incubate ni mo palang daan, pag-add ni mo sa kanipa yung another reagent na antigen-coated latex particles, so of course, tanang antibodies na bind naman sa antigens na present sa imuhang patient, alright? So, wala na yung mahitabo na lattice formation. Wala na yung pwedeng bind na antibodies aning latex-coated particles. Gets? So, muna siyang no agglutination is positive. That indicates it's a positive reaction ang no agglutination. Okay? It's positive for the antigen. In this case, antigen atong gidetect. Alright. Now, another scenario is, let's say the patient doesn't have the antigen. So, geda. So, nagets na unsa naging mga expected na mga results. Of course, pag-add mo sa reagent antibodies, wala may antigen na present. So, wala mo bind sa imuhang reagent antibodies. So, pag-add mo sa imuhang coated particles, antigen-coated latex particles, so the antibodies are free. Wala nakabind nila. So, they now bind with the latex particles na coated atong antigen. So, therefore, since na-bind man nila itong latex particles, antigen-coated latex particles, they now produce the lattice formation, which then results to agglutination. Gets? And that means a negative result if na agglutination. Okay? Gets? Ayo, please don't be confused, ha? From the very start sa type of agglutination, direct, indirect, reverse passive, di ba? All the positive reactions are agglutination. But dili lang sa agglutination inhibition ang positive kay no agglutination. Okay? I hope na-guess lang ang principle. Okay? And if malibog mo, just tell me again para ma-explain ako again. But I hope na clear lang to siya. Alright? Ayan, muna ang point. Kaya if wala na agglutination, okay, no agglutination, it means that the reagent, again, antibodies, have already been binded by the antigens found on your patient sample. Okay? So, pag-add sa imong reagent po the antigen-coated particles, okay, So wala na free na antibodies na mo bind ato mga latex particles. So therefore, walay lattice formation na mahitabo, walay agglutination na mahitabo, and that indicates a positive result because that indicates the patient is positive for the antigen na imong gitest. Okay? And if absent ang antigen sa patient, so free ra ang antibodies found in the reagent, okay? Then so pag add nimo atong latex particles na antigen, free ra man ang antibodies. So ang antibodies o ang latex particles na ang mo react, all right? And now they form the lattice formation which now results to agglutination. Okay, so that means it's a negative result. So the patient doesn't have the antigen. Okay? The antigen under study or antigen that you want to discover. All right? Okay, whew. I hope na gets lang, Lord, please. Okay. All right. So if you have any questions, feel free lang yun. Don't be shy. Okay. All right. So that's for agglutination inhibition. Diba? Kabantay mo, from direct to indirect to reverse passive, tanang positive results kay agglutination. All right? Dili lang ang negative, ang no agglutination. Okay? All right. Kanira na test pod ang no agglutination. Okay? All right. I think. Ayan. If I have students man from my AUBF last sem, so I think makarealize na muna katahong gimension sa ato ang pregnancy testing na different testing na mga immunoassays, yes, muna ni siya. Okay, so I hope medyo refresh na lang to or if wala na ako na further discuss to siya, so I hope mas nakasabot mo diri. Okay, sa mga AUBF ko dyan, alam niyo na kung sino kayo. Okay, alright. I'm watching you all, charot lang. Okay, alright. Next, another type is coagglutination. So, by the name itself, coagglutination, ang difference lang is, instead of latex particles na mong gamiton, what you use are bacteria. So, it's like a reverse passive type na antibody imuhang gamiton, ang imuhang ibutang sa surface. But instead of latex particles, you use bacteria. Alright? So, again, it detects antigens, and ang most frequently used organism is Staphylococcus aureus. And please take note, the strain na ginagamit nato is CoA1 strain. Alright? CoA1, one word ni siya guys ha, CoA1. Ayan, CoA1. Bayan, napakit naman ang handwriting ko. CoA1. Ayan, CoA1 strain of Staphylococcus aureus. Muna siyang ginagamit na strain for this type of agglutination. Coagglutination, it uses, again, pinaka-common Staphylococcus aureus. Alright, okay. S. aureus, sige daw. Unsa may mga biochemical characteristics na bi? Char lang. Okay. Coagulase positive, char. Okay. Anyway, bacte na. I miss bacte. Anyway, S. aureus, na siya protein A, di ba? One of its virulence factors, if you can remember. It absorbs or adsorbs, ihang kuwaon ang Fc portion sa imuhang antibodies. That is why pwede siyang magamit as a carrier molecule, no? For your reagents as latex particles. Parang siya ang latex particles this time. Alright? Ayan. So, and these particles daw, they offer greater stability than latex particles and they're more refractory. So, meaning, dili sila mo react to changes in ionic strength that could hinder or could affect the reaction or the formation of the lattice. No? Alright. Reactions are often difficult to read then. It's highly specific. So, when you say specific, it can really detect the antigen that you want, okay? But it's not as sensitive for detecting small quantities of antigen. I hope na-gets lang ang difference between specific and sensitive, ha? Specific is, you say that the test is specific if it can detect the antigen or the analyte that you want, okay? Sensitive, it can detect the analyte even kung unsa in smaller quantities, like in the smallest of quantities. All right, that's sensitive. Okay, so it can be specific, but it's not that sensitive. Okay, all right. So it's used in the identification of strep and meningitis and gonorrhea, Vibrio cholerae, and Haemophilus influenzae. So as you can see, it's also used for detecting other bacteria. So yeah, but mura siya point sa coagglutination. Instead of using latex particles to which your antibodies can like adhere on, you use bacteria. And the most frequently used organism is again Staphylococcus aureus. Unsa na strain? CoA1 strain. And why Staphylococcus aureus? Because it has a protein A which naturally absorbs the Fc portion of your antibody. Alright, so since Fc portion man yung kuwaon sa protein A, so ang binding sites, ang Fab kay free ra gyapon to react, okay, with the antigens. Okay, ayan. So non-specific adsorb reagent antibody through protein A, and in the presence of antigen, so you're detecting again antigen, okay, capture, and they result to agglutination. Okay, all right, ayan. All right.